Okay, here we record again. This time we're gonna go for this one. This is the section after even. I just added this section. So the first thing we're gonna do is bring in English again. Oh, that feels good. Um, the red really comes out really well, doesn't it? Compared to the blue. Whoa, I like the red. Let's see if the Cosmos. Oh, Cosmos also comes out really good. Okay, we have things that I would write with, which is interesting. So I love, well, that comes out really good. This idea is is basic and has no detail describing what the idea is versus the electron. What the? Okay. Um, I don't know why. So what I did was basically I I should double check this, but I said I love this idea and I put this into ChatGPT and make the English better by putting descriptions about electrons or something. And it gave a shitty sentence like this, actually. Uh, what the hell? Okay, I'm gonna change this real quick. This is awful. Um, uh, near the, my God, it's not even good at writing English. What is ChatGPT good for? Anyway, the having an electrical near the fan is a good idea. Computer near the TV is a good idea. Much better. What the fuck? Why could how, what the fuck was that idea of? Okay, so that was that was obviously a bad idea. Okay, I'll never do that again. Because that was the worst question worst. Uh, yeah. Maybe I should, yeah. Okay, don't trust English with it. Oh, what the fuck was that? All right, having an electrical. I changed it just right now because that was the awful sentence. What the fuck? Near TV is a good idea. So the first one basically shows you the basic detail that I just wrote. I love this idea because, and then now I changed this sentence because the earlier sentence was so bad that it had to be changed. So I changed it to having an electrical outlet near the TV is a good idea, describing the direction of the idea that's good, kind of like that. That's the idea I had. And what the versus is basically when we go to math, um, we go to math world. When we do absolute, we get rid of the details of the direction of what's going on, what's happening. Instead, we get the magnitude. I pressed something, I just dropped it to here, and I don't know what I pressed. Okay, so don't know what I pressed, but it didn't break anything, I don't think. Maybe I pressed insert or something. I don't know. Okay, now I press leave no smart key. I don't know. I have no idea what I did. But anyways, absolute get rid of detail. Why is that important? It's you can reframe you can reframe math in different ways. So in this case, but first of all, we're going to talk about 2D. So absolute value in 2D. Sorry, 1D. 1D. 1D has just basically two directions, negative and positive. As we said, a human decided this as our reference point, and we have a direction. You could say ball moves in the positive direction by the choice. And then this is going to be more physics than math, which is in the physics section later on, which I will describe the reference point, everything. Um, this is upward direction, and this is negative direction because we chose this as zero, basically. This is equal to zero when this is over here. Okay? So, now this is up and this is down. So if we don't care about the direction of this, we just show you, hey, this ball moves 2 feet up, 2 feet, 2 feet somewhere. And we have no idea. It could be 2 feet this way, 2 feet that way. We just know it moves 2 feet some direction. Now, a scalar has no direction. Now, what kind of things can have no direction? It's like pressure without area. Pressure without area is the most is a useful, not really useful, but it is useful concept. It basically is kind of like a push effect on all direction. It could be pushed in or outwards. We could see it like this. Um, until we have some kind of surface, then we have direction. We're using physics terms now. So, so pressure doesn't have what's the word? A direction bef without certain geometric factors afterwards. So you can describe pressure as like a magnitude. And this is a classic example I always think of, which will come up in fluid dynamics, which will be the way I showcase it, because I showcase this in I wrote this in a homework question, and the grader didn't say it was wrong, so I'm assuming it's right. So if it's something like this, I showcase the pressure like this basically. As you go down, it's a magnitude, and until it hits that flat edge, flat edge, it's just a magnitude thing. Once it hits this place over here, once it hits this place over here, oh, I don't like that. Once it hits this thing over here, that is when I don't know what's going on. Let's see. That is when we have a force. So there's a reason why pressure needs a geometry. I think um a simple way to say is F equal ma, right? Oh, what's going on here? Oh, nothing. Right? Oh my God. F equal ma, and then if I remember correctly, pressure equals F to um force divided by area or something like that. Actually, it depends on what kind of forces, but it's 2D right there. Anyways, um, yeah, and that also makes the whole thing confusing because then you need to look at the how the Navier-Stokes works with it, and it's a pain in the ass. But you get what I'm trying to say. That until there's a geometric factor, it's basically a magnitude in the end of the day. Um, is it important? Debatable. Debatable is it's like a more intuitive thing that you kind of know this about it. Now in Now we're gonna go into 2D, obviously. In 2D, we have is 2D is two-dimensional, right? It's an X and Y, right? So imagine we're doing, or let's just change this to not position because position sucks like this. It makes more sense to use uh U and no, U is always usually I'm thinking of fluid dynamics. So kind of weird. But so in this case, we're doing a. I don't know if you I should write vectors here, but if there's a velocity vector going this way, we know the direction and angle. But if we don't know, I mean, if you only know the magnitude, I don't like this either. If you only know the magnitude, you only know that the direction could be in this circle area, but we don't know where that velocity is going. Imagine a particle, and you know the magnitude, but you don't know where the direction is. That is what absolute value does. It gets rid of direction, basically. In essence, is getting rid of direction. Does that make sense? I hope it does. I think it does. So it's trading uncertainty. Um, why do you want that? Well, because of scalars. Scalars don't have direction, and vectors have direction. In the world of vectors, it's later in my book, but why not talk about it now? Um, if you have 5, 4, 3, that's a direction. So in this case, you have drawn a 3D directional field. This is always X, this is always Y, and this is always Z, and X, Y, and Z. So something like 4 over here, and then Z is 3, so we make it a little smaller, and 5 is the furthest. So 5 is furthest, so like this. So in this case, it's like cosmically over here, like that. That's the directional field. And then this is direction, but you can scale it by a magnitude, and then you can multiply a vector by some constant, which this constant is a scalar, which is a magnitude. I don't know why that would happen. There might be something which can increase this thing. Uh, well, it should be the same direction. You get the point. Well, is it important right now? No, but I'm just kind of showing you why someone might use a magnitude. Because when I was learning magnitude as a kid, I did not know what the hell this magnitude. I did not know what absolute value was for. It was like something you learn, but I thought it was completely useless because it's the easiest shit in the world when you learn it. It's like, oh, I learned you get you get a negative number here, -2. Well, just do absolute number -2. A very simple operation. Very simple operation. What does that really mean? You're getting rid of direction. Basically, you're forcing yourself to do direction later on, usually uh, with something else. Unless you're dealing with fluid mechanics where basically the direction is geometric. Basically, the geometry of the system determines the pressure, and then the pressure then, and I mean, there's also other things like fluids and the velocity and other stuff. But if it's stagnant, it's like this. But if it's like, well, if it's like something like in a field like this. The velocity is moving like this, and maybe you're making a vortex like this. Then you would have to consider other stuff. It's just a simple fluid mechanic question, a very simple one that considers nothing too essential, and we'll consider steady state because a lot of engineering question goes into steady state later on. Eventually, um, we'll start with something like v dot this equals 0 because in a fluid dynamic situation, basically it's continuity equation. Um, v let me use just index notation because index notation is way easier. So I shouldn't be doing this like this, but you get this like this equals 0, which basically means plus b y divided by vy plus vz divided by vz equals 0. There you go. Why am I doing this? I have no idea why I'm doing this. Oh my God, I'm such a dumbass. Let's just do vx equal if I want a rotational matrix, you need R. So you have to change it to cylinder coordinates. Oh, I'm not doing that. We'll do something very simple. Vx equal let's just say uh v equal x in the I direction. Oh my God, this is the most awful, awful. What kind of fucking fluid would do that? I don't know. Like I should do kind of know. But it'll be x divided by h or something. And it'll be something like this. Yeah, quick flow or something. Maybe I shouldn't do this. I don't know. I don't know. Maybe I shouldn't do this. I'm already in it. So basically, a lot of times, I'm just gonna say this is equal to 0 because the derivative goes away. Um, oh, wait, I'm wrong. I'm wrong. Vx equal y divided by h. Let's do that. So yes, that is correct. That is correct. What am I doing? Vx equal h. This is 0 then. And then you satisfy continuity, so you're good. I don't know what I was cooking earlier. I was doing something stupid. Um and then we'll do okay, why am I doing this? I'm trying to talk about absolute value. I got carried away to some fluid nonsense. Sorry about that. We'll just forget I ever even went to fluid mechanics. But now I need to prove to everyone that I actually do know my fluid mechanics. Damn, why the fuck do I do this to myself? Do I have to? No, but it's nice to do it. Fuck. I don't want to do it. I know that's wrong. Plus V dot density V plus no plus equal negative gradient P plus mu plus a square V. As you can see now, I proved I know my fucking momentum equation. Okay, now let me not do this ever again and move on. Okay, I don't need to prove what I was gonna do. This is 0, and you can expand this out, and then you can expand this out and plug in Vx equal y over h over here, and you get the pressure over here by reverse engineering the equation to get that. You do need to do a few more of the stuff, but potato to Panamo. Uh, and because it's non-compressible, it is decoupled from the energy equation, which is quite nice. Not really, because I think numerically it's more complicated. No need to know more about that, but uh, yeah. All right, well, we're gonna move on from here. Because I've been wasting so much time. I do want to talk about more about it, but I'm wasting too much time on that, and it's already been a long time. If you want to learn more, I'll make a video about it like in 2 years probably because I'm the rate I'm going, I'm gonna have to wait. You're gonna have to wait 2 years for it. Um, yes. Oh my God, I'm so slow. Anyways, and then you get delta P, and then delta P also gets delta P divided by X. You get three equations in the moment equation, by the way. So that one equation was a simplified version. What am I doing? All right, let me erase all this and just let me continue with this stuff. Okay, absolute value of X equal X negative X, and then this is X greater than equal to 0, and X. Okay. I just stopped getting myself into a weird situation. Um, okay, so here we say x is domain of real numbers. So infinity to negative infinity to infinity. So that's a domain where it belong to. And then we can simplify that as saying just equal to R, basically all real numbers. Making it easier for why does my eraser not want to work sometimes? Okay, so what does that really mean? It means if you put x equal to -4 and put that into absolute value, you get 4. Simplify. Because a negative number multiplied by a negative equals a positive number, and so on and so on. So if, why am I writing if? It makes me look like a slob. When I write it down here. So if I get if I get -2x equal 2, then you can say that it is 2 equal 2 and x absolute equal 1. You just move the 2 out and you're good because it doesn't affect anything. And I got rid of the negative because the absolute value doesn't really matter. And then x can equal 1 or -1. And I got that correct. Obviously, why should not get that correct? Anyway, next is absolute value of x plus 24 equal 24. This is a little harder. Um, by by definition, we know that it has to be something. So you have to actually split it to two questions. And I'm starting to realize maybe I shouldn't have done this. But you have to split it into x plus 24 equal -24. You know what? I do expand on this later, so I could just say expanded later. I don't like this. How do I put this? Um, expanded later in because it is expanded later on book. We're just doing a simplified version of it over here. In later in book, I go into magnitude thing, because in reality this form over here can be shown to be imaginary by EI factor, which means it's like some kind. You can show a dome like this, which. Was it EI factor? Yes, it was EI and then EI theta actually, which equals cosine theta plus I sine theta. So basically, this can define an absolute value, and you can show a loop like this and show two of these and show how the directional value goes away using the imaginary portion. It goes into real details, but yes. Well, let's just not talk about that for now. Um, because I don't need to. I mean, maybe I'll do it at the end of the video. Which I should. Yeah. So where was I again? I keep on going off topic. X plus 24 absolute equal 24. And why is this so awful? No, it's because I did it that way. Okay, and then you can see that plus 24 equal 24 here, and we can get x plus 24 equal minus 24. So far, we're doing simple ones that have two real solutions, and it doesn't always end up like this. Uh, this is 0. This is 0. Sometimes it can be one solution, there can be imaginary shit, and it could be weird. This is 0. No, wait, this is -48. And then you have two solutions here. Ching. Sometimes there's only one solution here and there's no solution here, and then you get a pain in the ass here. I'll spin it in the video. What the hell's going on? Okay. Next, we have a simple one, -x absolute equal 5. And as you know, you could just say this equals 5, basically. And you can, because it's just same thing. And then we can say is x equal 5 or -5. Now, if I have given you this question, you have two solutions too, x equal 5 or -5, same thing. Um, Yeah. Oh, let's move it over this. Now, I showed you those things. Ooh, let's move on now. Uh, to oh, negative 2x3 powered by equal to, and I give you the answer here. Here's the thing. Oh, let's not do that. Here's the thing about x3. Usually there is three solutions. There's three solutions to, oh wait, that's the wrong notation for, that won't work. So if there's a poly of order 3, and then we could just say that equals uh, n. N has three solutions. What equals 0. There's usually three solutions, usually. And it could be imaginary, it could be blah 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 blah, it could be three wheels, blah 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 blah. But well, in this I'm thinking right now, because we're doing absolute value, it's gotta well, what would happen is imaginary, right? Imaginary will say a plus b I. So if it was imaginary, can you get the absolute version of, oh, well, there's three solutions. I forgot about imaginary. Delete it. Unfortunately, I'm not supposed to teach you imaginary here. That would be way beyond my countability levels of absolute values here. I'm deleting that. Okay. But there's no reason for me to inject that to you right now. That is a bad idea. The last thing I have here is x, y equal uh, x comma y comma. And this is just a basic proof. Just first claim that this equals x negative x parentheses 0, and then x this. The same with y, I'm just going to say, but y version, like that. Uh, so this is just a y version over there. And then if x comma y is all going to the positive direction, we know that it's just a um, simply just that because nothing changes. It's just x and y. Um, but if you move over here, basically what you're going to have to do is if you have a negative x and y, look back over here to these things and go make an absolute back to it. That's all you do continuously, continuously, continuously with all three of them. It's kind of an annoying proof. It's not hard. It's actually pretty easy. Um, but honestly, it's not even, I won't even consider that a proof. Um, it's just algebra at the end of the day. But we're only doing chapter one, and we're doing basically 101 shit. Um, because we're not doing anything advanced, I don't think. So you could just say, I'm just gonna say it right here, negative xy equal x negative y, which equals absolute x y. And this is by looking at the fun two, and that's good enough for me because it's like no duh, that's obvious. And then if you have negative x, negative y, that equals y, and then so on and so on. It's not difficult. Like you just say that's that. Um, it's just annoying than anything else. You can make it more complicated if you want, but it's not. It's just more annoying than anything else. Um, I think there's an easier way for me to indicate how to do this one. Let me just put this thing and just screenshot it. and then put it over here. Yeah, this is way less annoying to write. Okay, so I screenshotted it. I can move from my tablet and explain it like this. So we start over here. And now this is positive, positive. So as you can see, you get x and x. And you see x and x follows over here. Oh, oh, like that. No. X goes over here, X goes over here, and you just get that. That's it. Now, if this is like this, you see this over here. Individually, you get negative y over here, and over here you get negative y. But notice that this is equal to negative xy, which is over here. And this can be translated to that basically if it's an absolute, right? And over here we have x over here, we have y over here, which you can translate to these two. These two come back over here, basically, and this shows up because this is also equal to next y, right? And then over here, absolute value of that is xy basically. Over here we have negative, and then you already know this one to be true. And we go back over here, same thing. It's not hard. That should not be considered a proof. I made that into a proof because we're doing basic 101 shit. Now let me go down to absolute value just to show what I mean. Let me go to absolute value properties. Oh, I have to clean this out. Uh, you see, there's two solutions. There's one real solution. Let me also make sure this no. Oh, there's imaginary solutions like this. Oh, it's funny. There's four solutions. There's the where's the oh, I need to clean this up so badly one day. Here it is. If we have if you look at this question over here, this is the full solution over here of this. Like, why not explain it while I can? I mean, it's not going to hurt anyone to explain what the hell is going on over there. Even though I'm going to make another video later on explaining this anyways, we can really relatively just explain it like in 5 seconds anyways. And this video is going long enough. I already talked about fluid mechanics for no reason, so why not just waste your more time of why waste more of your time, right? No one's going to watch this anyways. Um, Over here we have 15. You can indicate this as actually saying that this is equal to 10 EI theta. Why can we do that? It's because we're adding direction into a non-directional magnitude. So imagine you have a magnitude shenanigans over there, magnitude, and just say all directions are possible in 2D because we're doing 2D right now. So this is what we did by adding this portion over here. We're saying that all directions are possible. And in this line, we're saying imaginary is our direction with the real axis. And we're just saying, okay, all directions are possible. All directions are equal. Okay? Understood? Um, and now what that allows us to say is like this is happening, and there's two real portions if you want to see it. And then there's a bunch of imaginary solutions around it. And no, n- that's what we did. Because if you take a magnitude of this 2D thing over here, you get the magnitude. So, um, so that's why the imaginary is a solution. We just adding a direction to it, kind of like go here's all the directions that's possible with it. Um, yeah, yeah, that's it. That's basically how I imagine it. Um, to be honest with you, if you check over here, sometimes there's other imaginary solutions. Oh, there's supposed to be imaginary solutions to this sometimes. Two real solution, imagine real solution, one real solution. Since the first time I do imagine, no, there's another time I do imaginary. Okay, there's two times I do imaginary. Okay, so this time I'm just showing you can direction. I'm pretty sure. Is there anything else I should explain to you? Let me think. Well, this only works because this is like 1D, 1D, and then you're adding a 2D component to it. So you're adding you're basically getting imagine a imagine 2D, okay? Imagine a 2D world and use magnitude to make it 0D. That's what is happening. Uh, so I mean, and then why it doesn't work with a spherical thing is because imagine something like this. I mean, you can make it work, but I won't do it here. Imagine this, and the magnitude of this is uncertainty now. Uh, And that is kind of what's happening if you choose to do a 3D object into getting a magnitude here. And that gets a lot more complicated and cannot just be done by just a basic imaginary shenanigans. You kind of have to do vectors. I mean, still vectors, but it's less vector. It doesn't feel like vectors when you do imaginary numbers. That's kind of the essence of imaginary. Uh, it's kind of what I'm saying. So in reality, you are adding a vector, but you're adding all the possible direction in 2D space and then getting the magnitude. So the uncertainty range is 2D. But when you collapse it into a magnitude, you don't know which direction it is. It's no longer just so this looks like a very much a 2D question. Because it is. And then I'm collapsing it into 1D. And then you see how the X is a solution of all real. So when it hits over here, that's all the real ones. And then the imaginary solution also. So there's like three, yeah. And then it's kind of like I don't know what I'm saying. I am not. I need to sleep. It's like 1:10. I'm gonna stop here, but you get what I'm trying to say with imaginary. I'm just gonna stop here because I'm gonna yap all day, and I don't want to keep on yapping. And I'm not gonna sleep at all at this rate.